welcome to this talk about Istio's performance and scalability. We're going to talk about that. My name is Laurent. I work at Google. I'm one of the core contributors on Istio since before 0.1 a year ago.
I'm Fawad Khaliq. I'm with VMware, and I'm an engineer over there. I'm also looking at service mesh and Istio topics, and particularly around performance and scale topics.
Hello, everyone. My name is Surya Duggirala. I'm from IBM. Along with Laurent, I jointly chair this Istio working group on performance. Also, I work on IBM Cloud performance engineering.
Thanks. So I'll go a bit over what we're going to talk about today. We're going to tell you a bit about that working group that we have on Istio, how we study the performance and scalability of Istio to try to make sure it helps you solve your need without consuming too many resources. So we have a multi-level approach that we'll go over, and then we'll go over, Fawad will go over the environments that we're using. We're testing in a multitude of environments, and there's many scenarios that we're looking at. Then I'll take back the mic and we'll look at the characterization and probably more interestingly to you guys, the issues that we found, how we found them, how we fixed them so far. And then Surya will take on the mic and talk to you guys about how we study in a realistic application, how do we study the performance using a realistic application benchmark and the results there. And at the end, we'll talk about what are the next steps for Istio. It's a very new project. There's a lot of cool features, but there's a long road ahead in terms of what we can do to make it perform and scale as best as we can. And then we'll take some questions. So I'm assuming, so this is the work group. I'm assuming everybody by now should know what Istio is, so I'm going to just skip over that. If you wanted to learn about Istio, the previous talk was about Istio. So our working group is meeting regularly, and since December we started that effort. And I want to say a few words about our approach. So there's many levels in which we can look at the performance characterization of a system, and we do it at multiple levels. First, a lot of Istio is written in the Go language. Go makes it fairly easy to write benchmarks. So we do have a lot of benchmarks at the component level to try to make sure that, for instance, mixers library are as efficient as possible in processing the rules. And we've made significant improvements in the last few months in Mixer, for instance. The second level is we do synthetic benchmarks. So we simulate the setup. And for that, we wrote a tool called Fortio, that lets you basically be a next generation echo server, load generation, and lets you visualize the results. We also then at the next level use something that's more realistic for applications, which is the BluePerf. It's also open source like Fortio. So you can reproduce the results that we produce in your environment. And this is what we're trying to do. We're trying to set up some base tools, some set of libraries that anyone can use in order to test in their particular cloud environment or their particular setup, because Istio works on Kubernetes, but not just on Kubernetes. And there's many dimensions, whether it's the payload size or whether it's the protocol, you're doing HTTP, you're doing gRPC, you're doing something else. So we'd like to leverage the community so everybody can participate and help us find bottlenecks in different dimensions. And then the last point, which is actually very important in what we're doing, is we're doing automation. We're making sure that every release, every night is being tested, such as we find regressions early, or we can track the improvement over time of the performance. And Fawad now will go over those environments.
Thanks, Laurent. Packed room here. I'm pretty sure a lot of you guys are users of different type of cloud environments, AWS, Google, IBM, on-prem, OpenStack, maybe Cloud Foundry, and looking at service mesh. and must be wondering if these guys are actually testing or looking at scenarios from your angle. So I'll try to cover most of these. If there's something which we are not covering, please come and talk to us after the presentation, and we'll be happy to talk about those. Or more than that, just come and contribute as well to the group. So what I'm going to cover is the different environments and scenarios, some of those that we have done so far as part of the working group. And those include GKE, IBM, AWS, Azure, and some on-prem data that we got from one of the customers who's using these tools. So let's go over how it looks like in GKE. This is part of the Istio repository, where there is an environment setup, a framework that you can use to bring up the entire end-to-end Kubernetes deployment with Istio, Fortio, and there are a few test cases that you can run. For example, one that you see here is where you can deploy Fortio as a client and a server both, doing part-to-part performance testing. And you can just, for example, what you see over here on top right is a pod Echo Server 1 and Echo Server 2. And both of them have sidecars, so you will check kind of data plane and also some mixer rule checks and check performance on that topic. The other one is where you can also include ingress to see the results for your performance, and that traffic comes from a Fortio instance running on a GCE VM outside the cluster, Kubernetes cluster. And the third one is where you want to run test cases without Istio to see the comparison of how it looks like with Istio and without Istio, with ingress, without ingress, etc. That's one of the things which is there. Laurent is going to go into details of some of the results we have captured from this scenario and this environment. Another one is an IBM Cloud. What Laurent mentioned was regression control. This is part of the automation and CIA automation, which provides us data on how daily builds are looking. And this is the sample app which is there. It's kind of looks like a real deployment app, which has a flight authentication piece, a customer booking, has a way to publish the data to Grafana that you can go and look at. Surya is going to cover this, and we'll give you a small demo of this one as well. And in this one, instead of using Fortio, it uses JMeter, which runs on a VM outside the cluster and generates traffic, and most of it goes to the ingress. So it kind of looks at the holistic view or real industry use case point of view. Then VMware, we've been looking at from AWS perspective, and what it does is that you could bring up a Kubernetes cluster using KOps. And there's a Jupyter notebook which allows you to bring up your cluster. You can define what kind of test case you want to run or scenario you want to run. And it's super configurable, so you can just define like number of Fortio instances. So this Fortio is being used over here for load generation, but on the server side, we're using LWAN, which can handle 100,000 plus requests per second. It's supposed to be super robust, and it's working well for us. And the kind of scenarios that we started was without Istio, with Istio, and with auth, and then also moved to without mixer to see the comparison of how numbers look like. If we go and talk to anyone, if someone comes and like, I'm going to adopt service mesh, and does it like what's the cost that I'm trying to cover? So there are some numbers that we captured from here around latency, etc. And Surya will talk about some CPU usage numbers will be used over there. So just to give an example here, this is some sample deployment that you can use a Jupyter notebook and just enable Istio and then run the scenario again to capture the results. And then you can also enable authentication to capture the same scenarios for that, or same results for that. And an example capture of the plots is here. These numbers are from an older release of Istio, which are like 40,000 QPS for different number of clients of Fortio, which can be scaled up and down, and captures different kind of percentiles, 50, 75, 90, 99, 99.99. And as you see over here, there are three bars for each of those. One captures without authentication, the other one captures with Istio, with authentication, and the third one is with no Istio. It gives you a good comparison. And we'll talk about some of the improvements we have done in this area. Another topic, another cloud environment where one of our colleagues from the community, Caddy, has been running these scenarios inside Azure. And what he has is he's been running with JMeter, which talks to the Azure load balancer, and it looks like has the Istio ingress configured for the traffic path. And there's a target service which has two nested services. One is an HTTP backend, the other one is a gRPC backend. And it's running on AKS cluster. And how it looks like is some results that we have captured over here is you see on the left side, it's first 15 minutes captured, the service, target service is sending traffic to the HTTP backend, and afterwards it's sending the gRPC backend, and you see some difference over there. There, of course, you may think there are many variables here. It could be the application code as well, but there is some numbers we have captured over there in terms of differences between different applications, different outputs. And the last one I want to cover is the on-prem, where Fortio is being used to generate traffic, and is a hardware load balancer. This is a completely on-prem deployment. And the service looks very similar. We had to anonymize it because of the customer. And there's an entry service which has 2 nested gRPC backends. And there are some results being captured over there. This is a small presentation, about 30 minutes, 35 minutes. So we could only give you an overview. If you need more information, you can come talk to us. And with that, I'm going to hand it over to Laurent to talk about performance characterizations.
Thanks. Thank you. So as I mentioned earlier, As I mentioned earlier, sorry, one of the way we characterize the performance of Istio is through Fortio. So the idea of Fortio is kind to be a modern microservice area, Swiss Army knife of network testing. So it's doing a lot of little function, all that in a very small image of a few megabytes. So you can deploy hundreds of it if you wanted to in order to simulate a fairly deep or wide cluster. And still be very efficient. So it's also a Go library, so we use it inside Istio to do functional testing, not just performance testing. So for instance, we send exactly 200 requests, and we make sure you can read the map of the result codes, and we make sure that there's no errors or that the metrics actually add up exactly, and there's no errors. So it has a component which is a command line, and as a client, as a load generator, and also a server side, like an echo server, a bit like HTTP bin, where you can customize the result code that it replies, the payload size, many parameters. So the key element there is to run the system at a fixed QPS. So what you want to do when you're trying to characterize performance is you want to push your system higher and higher, and then you find the point where it starts to saturate. Maybe the CPU is saturated or the IOs are saturated. And then you want to walk back from that about 80% and run the test at that fixed QPS in order to get the latency that you expect to get, the distribution of latencies that you expect to get in your production system. So this is one of the main features. It can run at a set QPS. And there's a bit of a way to visualize the data. It's also fairly high performance because it can easily do 400 QPS on self-testing. So I'm going to do a bit of a small demo of the actual system. So so let's start here. This is it's big enough. So as you can tell, it's built by engineers, so the UI is it's not supposed to be pretty, but it has a bunch of features. You can set up whether you're going to do a gRPC or an HTTP load. This is the UI to actually create a load, so it's going to run against itself. And the echo server that's running, you can tell it, for instance, in this case, in 5% of the request, introduce a 5 millisecond delay. And also in 0.5% of the request, please make a 503 instead of a 200. So we click here, it runs against itself, and then you get the result. And as you can see, there's indeed like a bump there. That's the long tail of the data. You can see it a bit bigger if you put in log, or in log like this. And you can also see the result codes there that are about what we asked. So that lets you kind of explore, like you have your system and you try a few things, you explore it, and then once you've explored it, you bake that into a scenario, and then you run that scenario build over build. And that's what we're doing here, where we we have the automation that runs now for every release on both of our release branch and the master branch, and you can visualize then the results. So I'm not going to show you the daily build, but I'm going to show you what happened in the last 3 months for our actual releases. So this is the scenario 1, the service 1 to service 2. In the picture earlier, there was 2 services, and then we have what I call a cache busting rule. So there's a rule that makes it that in one direction, the mixer results are never cached, and the other direction, they are always cached. So that gives you a 0%, which is the worst case scenario, and 100%, which is the best case scenario. And then you can adjust those 2 numbers to get an idea of what it's going to be for your actual cache hit ratio that you expect. The mixer dashboard also shows the cache hit ratio, so you can see in your production deployment what cache hit ratio you actually get. So here you can see the evolution. This is the 0.5 release, in the middle the 0.6 release, and the latest release, because 0.8 is not out yet, which is 0.7.1. So in that setup, the black line is the QPS. You can see that we went from about 700 QPS to 1,000 QPS, and now to above 1,700 QPS at the max. The latency obviously is not great. The P99 is very high because we are pushing the system there. It's like CPU bound. So here we can compare two data points, right? This is 0.6, this is 0.7, and if you put the 2 together, you can see you can exactly compare exactly the distribution of data and the curve of the percentile, cumulative percentile. I think I'm going to go back to the presentation. But if you have any more questions, or you can look up it's on GitHub, Istio/Fortio. There's a lot of docs and examples. And that data is on fortio.istio.io, so you can go look up. You can explore the data that we produce and the scenarios on your own, I guess. Okay, so this is what I showed you. So now for the interesting things, like how did we get, how was it like 600 QPS and now it's 1,700 QPS in 3 months? So what happened? Well, a lot of it is, what happens when you write production software is you write it and it seems fine, and then you load it and unexpected things happen. One easy way to get into trouble is logging, paradoxically. So to do a good job, you want to log important events such as you can troubleshoot what's going on. But then from a production point of view, depending how you do your logging, you can end up having either too many IOs, log processing can slow down your system, or even serialization, where your multiple threads are trying to all log something and they can't. The throughput drops. So we found that in Mixer, we were logging things for every single check, and that's way too much logging for outside of troubleshooting. Another good one that happens is when you load test or you run a long-running test, you might discover a memory leak. So in this case, we had in the Zipkin library, there was it was spawning Go routines, unbounded number of Go routines, and yet all accessing a single lock to try to extract the data out of that lock. So it was basically consuming memory by consuming Go routines. Thanks to the reg patch hole that Surya is going to talk about, we found that at one release, we actually were doing twice the number of mixer calls. There was a mix-up in the envoy configuration of the filter, and there was 2 entries for the mixer filter. So we were doing twice as many calls, which obviously doesn't improve the throughput. We're also doing work at lower levels. So in our team, there's people working on envoy at the lower level, like in the TLS libraries, and we made a fair bit of improvement in the handling of TLS. Likewise for TCP and half close issues that were causing both functional and performance problems. if you recall, I mentioned we have that cache busting rule, right? The way that cache busting rule is, you can check it on GitHub, is it does an AND between something that's either always true or always false, and then evaluates something that reads from the request ID, which is always different, so cannot be cached. Well, there was a release where the short-circuiting wasn't actually working, so the 0% cache and the 100% cache were actually always the 0% caching. So we found that and we fixed it. There was another issue at some point. The source IP address was part of the cache key. So obviously, when you're on an ingress, if you put the source IP as part of the cache key, you're not going to get a very good performance. So we look at performance, but we also look at scalability, right? So when you add hundreds of services, you have to make sure that Pilot and Mixer and each component of Istio can handle that scale. And there was a bit of a problem with how we were using the API server Go client library, and we ended up crashing Pilot fairly early with excessive memory, so that was also fixed. So there's two items that we're still working on. Whoops. Everybody can see my password. Wonderful. Okay, so so there's two items that we're still working on. I'll talk a bit about the last one because it's a low-hanging fruit, right? The cache, the way the cache works today is that it's going to cache the mixer results for up to 100 requests or 1 second. And this is just what happens, what we have decided like a year ago. We just put that value as the default value, and we haven't really looked at it until recently. Obviously, it's a bit excessive, because if you make a policy change that it applies exactly within 1 second of your policy change or 100 requests is too much. So we could easily put that to be 1,000 requests or 5 seconds, and we would get a much better cache performance. So we're going to make that change and make it configurable so you can change it to whichever you want. And the other item we're still working on is which we're trying to explain why the mixer client performance doesn't seem to be what we expect, because when we test with the internal mixer client in Go, we get much better performance than what we get end-to-end with Envoy. So we're going to fix that too. So in summary, the work we've done over like the last 3 months, we got the P50 latency down from 34 milliseconds all the way down to 14 milliseconds, and we got the QPS up from 700 to 1700 on a cheap hardware, like a 2 vCPU machine. So those numbers are not the absolute numbers that we want to have, right? We want to have single millisecond overhead for Istio. But the trend is in the right direction, and by end of year, we're committed to work toward those better goals. That's another view of the improvement. 0.4 is even older, and that's that data. And now I will hand it to Surya.
Thank you, Laurent. As you can see, as Laurent and Fawad mentioned, from a community point of view, from Istio community point of view, we had 3 goals. We want to make sure that there is a regression mechanism built in as we develop the service mesh. And the second one is actually we want to make sure not only the specific primitive so that you can go deep and fix any design issues, but also go in like a breadth-wise, you want to go to the multiple industry use cases and actually work right at the beginning itself to understand and fix any kind of performance and scalability issues. Towards that, as we have introduced the regression patrol, one of the benchmarks that we have used is called the Acme Air BluePerf. It's actually open sourced, so all of you can actually take a look at that. It is basically a flight reservation system. It has 5 or 6 specific microservices. So you can actually see that when you deploy this, it's actually being now run on IBM Cloud, but it's actually istio.io. You can actually go and see. So what will happen is, if I'm the mixer developer or the pilot developer, I go and just integrate my code changes, and every night there is this Istio regression bucket. It runs in the midnight, and you can actually see the results and then see it's actually color coded. If you see a much bigger change in performance, if it breaches the threshold, you can actually see that. So what will happen once you see a regression, right? So you can actually see this. So people will come, in the interest of time, actually we videoed it, this one. So they will go and check it out. Okay, what is the latest build like? We have 3 scenarios running. So Istio full, that is the default configuration. He'll go and check. These are all automatically generated data. So they'll go and look at it, whether pilot, if I'm a pilot developer, I'll go and check, oh, is there something that I have done wrong here that created the regression here? We have an integrated dashboard. You can see the Istio and our own custom dashboards put together. And you can see in this, the worker node, all the metrics that you have, whether you have a disk issue or an I/O issue, or you have any other specific issues that crept in that caused the regression. And you can actually look at the Istio dashboard and then see whether you have any specific service level problems that you have. Maybe you have a sidecar issue, it's taking more CPU or memory. All those things are actually automated. And since we rolled out, we have identified many regressions, and actually this is improving the quality of the Istio service mesh itself as we are developing. And I would like to go and show you how the whole network traffic flows through. This is the one that's running on a 3-node cluster. You can see this is the service mesh deployed on a cluster, and this is like without any load. So you can see the pilot and sidecar interaction, the packet that's going there, network traffic. And now we're actually going to drive some load here from JMeter. Now once you send the load from there, the traffic will go, the HTTP requests will go through the Istio ingress controller, and you can actually see once the load kicks in, you can see the network flow, how this whole traffic is actually going through, and we can identify any kind of bottlenecks in the whole system. And you can see that traffic going through from the client to the Istio ingress controller. Now it'll get into the flight service, and then the flight service is the main service that takes most of the transactions, and then it'll get into auth service, booking service, and others too, right? You can. So this is one way to clearly see whether you have any kind of an issue in the system. And if you see some kind of a red dots that shows some kind of an errors, you can see the incoming connections and outgoing connections here. How many transactions each of those services are taking. What's the throughput that you're getting, what is the latency, all that can we clearly see. This will give a pretty good overview of how Istio is performing and scaling in a realistic customer application. As you can see, there are config A and config G. The way we develop this is actually we have a default configuration we look at, and then we disable the mixer, we disable all the other components, and then look at the performance of the Istio ingress controller, right? Just we want to make sure that which component is actually having issues. And what are the different industry use cases that we are using? Right? You can see this is the polyglot microservice. Each service is developed in a different language. One in Java, Spring Boot, Go, and you can see that in Node, right? So it's available. It's an open source, so you can actually go and take a look at Blueperf. And another thing that, because Istio, there's a lot of interest from the community, from the industry, we want to make sure that the real customer use cases are being looked at as we are developing this framework. One of them is the online retail online banking application. We have enabled Istio with that. This is the application that's actually in production in one of the North American banks. We have what we have done with this is actually we have applied Istio Service Mesh, and we drove this to almost 4.5 billion API calls per day. We want to really push that to its limits. That's without Istio. We could reach 4.5 billion, but we want to understand what is that additional capacity that you need, what is the additional overhead you have to pay when you enable Istio, right? Those are the things that we are looking at. Another industry benchmark that we are looking at is in the healthcare industry. That is the typical backend for front-end microservices pattern is another thing that we are actually looking at for Istio. So this is the online banking application. So you can see with and without Istio, what is that additional overhead right now? You can see is around 56%. So you need another 50% additional capacity to get the same kind of throughput. As a community, we are trying to, as a working group, we are working hard, as Laurent mentioned. We have a pipeline of things to optimize. One of the main things that we are trying to look at is the mixer overhead. But right now, you can see a typical industrial use case. You need, this is the distribution. Without Istio, if you distribute where you're actually spending the resources to get that 158 million API calls per day at around 330 millisecond response time, you can see the OLB orchestrator is taking around 150%, and stub is taking 120, and ingress is taking 65%. So what will happen if you apply Istio Service Mesh? You can see this. You are paying almost like 280% with Istio Mixer. Istio Ingress is around 140%. So you can see why this additional overhead. Right now, the main focus is on the mixer. We are working on that at this point. So another area is because Istio, if you see, there is a sidecar pattern. So you have, for each service, you have a proxy, that Envoy proxy attached to it. So as part of our analysis, we're also looking at what is the impact of the sidecar. What is the impact when you have an egress traffic that's going out to a public service versus the same traffic going to an on-premise service? There is a big difference in both of those two. So all those things, actually, we are working in the community. And one of the other things that we really want help from you is, as we are continuing to optimize this whole service mesh, we really need your help because, as you have seen, we have lots and lots of new optimizations and new workloads. And of course, we are covering multiple clouds, like AWS to IBM Cloud to Google Cloud to Azure. So we would like your help to expand and broaden that as well and be a participant for this work group. And we also have and need some help from the contributions from the Fortio side. And our goal here, the things that we are working right now, as I mentioned, the regression patrol, right now daily it runs. So our goal is we are trying to build a kind of a bot as well, so that automatically, if you find a specific issue, it can actually log the issue and send a like a Slack message to a specific channel, maybe for pilot or mixer. So those are the things in the works right now. So we need your help in continuing to push this and optimize. Our final goal here is to reduce the additional overhead less than 10%. So with that, any questions?
You have to come to the mics in the middle if you have a question, if you can. No. Come on, a question. No questions. No? No questions. Come on.
Thank you.
Thank you.